In the past few weeks, we have learned the asphalt mix design, the design of flexible pavement, and rigid pavement. Today, we are going to learn the pavement maintenance. I will introduce a series of pavement problems and the maintenance practice. Like all other structures, pavements are subjected to deterioration, which commences as each part of a pavement is completed. Some defects, which are visible or measurable evidence of failure or other undesirable condition, may affect the safety, serviceability, structural capacity, or appearance of the pavement. If the pavement is to keep the standard of service for which it was designed, maintenance must begin as soon as construction ends. The maintenance refers to the repair of defects and attention to the road structure and associated facilities to ensure the preservation of the pavement and the convenience of and safety of road users. The primary objectives of routine maintenance are to provide safe driving conditions and a uniform road surface to minimize the rate of deterioration of the pavement. Maintenance may be divided into routine maintenance, preventative maintenance, and rehabilitation. Routine maintenance includes activities which address minor defects on the carriageway and structure of carriageway, like drain clearing or grass cutting, and some essential activities to remove obstacles from the road and ensure a base level of road safety. Preventive maintenance includes works that are intended to reduce future deterioration by timely surface interventions, to limit the need for expensive rehabilitation, and to ensure minimum skid resistance and general safety levels do not fall below minimum accepted levels. Rehabilitation includes works that target roads with road quality deteriorated significantly or which display inadequate structural capacity for current or future traffic loading. This lecture will mainly discuss the routine maintenance of drainage elements, flexible pavements, and rigid pavements. Water is the most significant cause of damage to the pavement structure. Proper water drainage is important in maximizing the life of the roadway. The drainage system is one important part of any road, and it ensures a consistent program of inspections and maintenance for efficient operation. It has the following main functions: removal of rain or flood water from the carriageway, the road formation and the road reserve. Normally, there should have a slope in the road for the water to flow to the drainage. But if the road surface was damaged or reshaped due to the traffic loading or the environmental effect, like temperature, then there might have accumulation of water on the road, which affects the traffic and causes damage to the pavement materials. The second drainage function is the interception of surface water flowing towards the road formation and its disposal downstream of the road, so that it will not cause damage to the road or to adjacent property. Thirdly, it could intercept and dispose of groundwater that would otherwise penetrate the subgrade or pavement, which will eventually reduce the strength of the materials that support the running surface of the road. For some places, there are permeable backfill to facilitate the flow and collection of the groundwater to the interceptor drain pipe. If there's any failure of the drainage system, then the accumulated water will cause damage to the pavement structure. If the drainage system does not function well, then the following problems may occur. pavement break up. Potholes, surface cracking, shoulder disintegration and separation, saturation of the base due to the penetration of the water, and even total pavement failure. The drainage system should be inspected regularly. For example, every 3 months. During and after major storms are the best time for inspections, so any issues can be found at early stage. For any critical areas, they need to be patrolled during the storm, and any debris need to be cleared. The surface drainage is mainly table drains. The table drains mainly collects water that has fallen on the carriageway or the batters of a cutting and flowed to the edge of the formation. The table drains are essential wherever the road is in a cutting or flat terrain. Because table drains are often built on very flat grades to suit the road grade, they must either have a large cross-sectional area with frequent discharge points where the water can escape. Depending on the nature of the material in which they are constructed and their longitudinal grade, table drains may need to be lined with stone, concrete, or bitumen seal to resist scoring. Table drains require frequent maintenance to remove any stuff that may block the flow and to restore the original shape. If you look at this figure, the vegetation is helpful in preventing erosion of table drains by holding the soils, but overgrown vegetation and weeds causes blockage, so table drains need to be well maintained. On the other hand, scorer in table drains needs prompt attention to prevent serious damage that may lead to undermining the drain landing, the carriageway, or the cutting batters. Whenever a table drain is susceptible to scorer, it is usually necessary to line it with some type of durable material. For batter drains, where water is discharged down fields or cut batters, if the water flows very fast, it may result in serious scoring of natural materials. So it is generally lined with concrete, metal, or some other durable materials to avoid or reduce the erosion. Install energy dissipators at outlet of covers is another way to prevent scoring. It is important that batter drains should be inspected frequently after major flows to ensure they are in place, functional, and clear of debris, and immediate steps taken to make good undermining and repair and breaks in the landing. Where possible, the flow of water in batter drains should be observed during heavy rain to assess their adequacy. Other types of drainage are catch drains and banks. Catch drains are usually open earth channels with soil from the excavation being placed on the lower side to form a bank. The catch banks are small earth levees constructed from imported material. The primary function of catch drains and banks is to intercept surface water flowing towards the road formation. The corresponding maintenance involves regular inspection, clearing obstructions, repairing bridge banks, and filling the scorers. For surface drainage, proper crossfalls normally at in between 4 to 6% are needed. Otherwise, the concentrated sheet of water may form, which may adversely affect the serviceability of the road. This may also cause potholes and other defects. On smooth surfaces, the high-speed vehicles may aquaplane, resulting in loss of traction and control by the driver. If water flows or ponds along the edge of a hard pavement and a softer shoulder, scorer will develop, leading to dangerous conditions for vehicles and loss of pavement edge support. The sealing of cracks and filling of local depression are necessary for maintenance. The seal should be maintained in a waterproof condition by the prompt sealing of cracks in the surface and by filling minor depressions that would hold surface water. Culverts are important structures in any road drainage system. They provide the only passage for surface water to flow from one side of the road to the other. Failure of the culvert may cause damage to the road formation if it is overtopped by flood water, or damage to the culvert or formation by scorer due to high velocity. Regular systematic inspection is the most important, followed by appropriate remedy measures. Maintenance of the culverts includes constant clearing of debris and any growth from the channel and inlet and outlet piece. Special consideration needs to be taken after heavy rainfall, forest, or bushfires, or in seasons where trees shed their leaves. The accumulation of silt or drift sand in the culvert barrel must also be removed periodically by mechanical or hydraulic means. Subsurface drains, also known as subsoil drains, are generally constructed near the outside edge of the pavement. It is normally parallel to the center line of the road. Two main purposes of the subgrade drains are to lower the level of the water table and to intercept or drain underground water trapped or held by impervious material. It is difficult to maintain the subsoil drain. Frequent inspection to check the drain is not clogged is needed. If necessary, drains should be dug out and relayed using a practically designed filter material. Underground drainage systems are rare in a rural situation, are common in urban or built-up areas. Stormwater drainage or underground drains are installed where the surface drains of sufficient capacity to handle the runoff can't be constructed. Blockages occur when silt and other debris block the pipe inlets or the pipes. Frequent inspection and clearing of the drainage systems is essential, as otherwise serious damage can be caused, such as flooding of the road itself or any other properties. When construction of structures such as bridges, culverts, or pipes are not appropriate for or can't be justified, floodways and falls could be used. So obviously they are mainly applicable for low traffic roads. Floodways and falls are either intended to be covered by deep water for short periods or to maintain trafficable for extended periods. Normally, the pavement of the floodway consists of hard, durable material that is stable and traffic when it is wide. The batters of floodways must be composed of material that will resist erosion by flowing water. Quite often, the floodway is supplemented by a culvert to take low flows to reduce the frequency and duration of inundation of the pavement. Maintenance of floodways and faults may be divided into three types: dry weather, the pavement, batters, and supplementary culverts require routine maintenance similar to that of normal road. During flooding, regular inspection is necessary to ensure that the floodway is safe for traffic, because deep holes and washed out beds may not be apparent to all drivers. After flooding, high priority must be given to the restoration of physical damage so that the floodway is safe for traffic and is not further damaged by subsequent floods. This is a good video explaining the importance of roadway drainage, including the surface and subsurface drainage, drainage systems, and drainage inspection. It also contains the following contents: the slope and banks of drainage system undercut by erosion, some environmental issues in maintenance of road facilities, and liability for elements of design and maintenance. This video is a bit long, so you may like to watch it after the class. Now let's look at the details of pavement maintenance, both for flexible pavement and rigid pavement. This part covers typical defects and repairs of to bituminous surface pavement, which can be performed economically by a road maintenance crew. It is essential to maintain the road surface in a trafficable condition, so temporary repairs such as patching and crack sealing may be necessary, pending later resealing, rehabilitation, or reconstruction. The routine maintenance of flexible pavement can be broadly divided into the following categories: potholes, edge defects, surface defects, shape correction, and pavement cleaning. We will go through the details of each category in the next few slides. More extensive minor surface defects usually require resurfacing, whereas more extensive pavement or subgrade failures may require rehabilitation or reconstruction. Many defects result from the presence of excess moisture in the pavement surface layers or subgrade. So one of the most important functions of surface maintenance is to prevent water reaching or remaining in the pavement. Potholes are usually due to a cracked bituminous surface, allowing moisture to enter the pavement. The pavement may soften slightly, or water may penetrate horizontally under the bituminous surface. In either case, a small area of the cracked varying surface is likely to lift out under the action of the traffic, starting a pothole. Such potholes usually appear after rain. The repair of potholes involves the squaring of the hole and vertical trimming of edges and removal of loose material prior to reinstatement with gravel or fine crushed rock. And this is to compact and seal the surface of the patch, or use hot asphalt mix to fill the hole and then thoroughly compact the asphalt, or cold asphalt mix to firstly strengthen the patch to prevent pickup by traffic, and later on the surface of the patch will be sealed. If there's any damage on the shoulders, it will result in insufficient side support to the pavement and inadequate strength of at the edge of the pavement, or entry of water through the shoulder. This causes fracturing or breaking of the edge of a bituminous surface. Hot or cold mix asphalt is normally used to repair edge breaks and is placed and compacted to conform to the level of the adjacent seal. The following are the surface defects and the treatments. Stripping and leveling are conditions in which the sealed pavement surface becomes rough in texture due to a loss of aggregate or binder. Stripped or revolved surfaces will require binder to be added. The rate of application depending upon the amount and condition of the existing binder. If there are small areas of stripping or reveling, they could be treated using emulsion, binder, and aggregate or grit. A flushed or bleeding surface is often due to too much binder on the surface. The fatty surfaces become soft in hot water and slippery in wet or frosty weather, while stick surfaces are hard, smooth, and slippery. The successful treatment of this condition is difficult and requires careful consideration and field trials before any extensive work to be carried out. The most common temporary treatment for flushing or bleeding surfaces is the application of small stone aggregate. Normally, the maximum size is 5 mm, or grit or sand. Cracking is another common issue, and there are a variety of reasons. Cracks occur on the pavement surface, allow water and impressibles such as sand, dirt, and other debris to penetrate into the pavement structure. This penetration drastically accelerates the deterioration process. It is important that the initial cracking be investigated so that appropriate remedial action is taken later. Neglecting cracks will lead to accelerated cracking and other types of pavement distress. Sealing the cracks prevents further weakening of the pavement. If the cracks are wide enough, then it should be thoroughly cleaned with compressed air to ensure a clean dry channel and to optimize adhesion of the sealant to the crack surface. This is one of the most important procedures and crack treatment, since most recorded failures are due to loss of adhesion. Then it is filled with an unmodified cold purl binder with low viscosity to ensure it to be poured into the cracks. Care should be taken to ensure that the bitumen or bitumen emulsion used does not breach across the crack and the surface. Evidence of alligator cracking is an indication of pavement fatigue failure, and crack sealing is not appropriate for these areas. There are some alternative treatments such as power routing, specialized mechanical equipment, hot purl rubber, or polymer modified binder, and or proprietary sealants. As a result of bituminous surfaces movement, shaving may occur, which is a fairly regular waviness. Bulging of the road surface may also develop parallel to the direction of traffic and often at the edge of the pavement. If the bituminous material has been compacted by traffic to a stable condition, it may be practicable to fill the depressions with hot or cold mix asphalt. If it remains unstable, it will be necessary to remove the unsound materials and replace them with stable hot or cold mix asphalt. Rutting of the pavement is usually in the form of depression in the wheel tracks. If there's no weak pavement or subgrade movement, then the treatment will be same as described for shaving. If any faulty pavement or subgrade material are observed, then it has to be replaced by suitable material. When a fill or backfill has been inadequately compacted, such as at bridge abutments or service trenches, large depressions occur in the pavement surface. Depressions may continue to increase in size and depth through consolidation which may require deep-seated correction. Hot mix asphalt would normally be used to make a surface patch. Pavement cleaning is an important routine maintenance activity to ensure the safety of road users. Foreign or loose material, particularly at or near intersections, roads with spray-sealed surfaces, or unsealed roads and large obstructions can easily be mitigated by cleaning the pavement surface. Pavement cleaning may include pavement sweeping using different types of brooms, removal of road animals, and removal of vegetation like grass or moss. Identification of the cause or source of foreign or loose material is an important follow-up maintenance activity to reduce the likelihood of reoccurrence. Now let's look at some defects or rigid pavement. The main cause of defects in concrete slabs is movement of the subgrade due to differential settlement, plastic flow, or washing out of the subgrade material. Although the actions of traffic and weather also contribute. The common defects of concrete pavement are summarized in below. Subsidence of a slab, shearing or bending of dowels at construction or expansion joints following differential settlement of slabs, open joints which lead to ingress of surface water, popping or flexing of the slab and the traffic, causing the ejection of liquid mud from the subgrade, spalling or cracking of slab ends and corners due to traffic action, cracking of the slab allowing ingress of water and settlement, and finally slippery surface. Some forms of damage and deterioration in concrete pavements are difficult to detect in the early stages, and the first evidence of their presence may be complete failure of the slab. In many cases, one defect can lead to the pavement, to the development of others. Below is a figure of the concrete spalling of the rigid pavement. The rectification of defects in concrete pavements is beyond the scope of routine maintenance. However, some temporary holding repairs could be undertaken. The most common routine maintenance activity on concrete pavement is temporary repair of spalling. Cold or hot mix asphalt is often used for this purpose. It is important to clean out the spalled area, apply a tight coat to all surfaces, and adequately compact the asphalt to prevent loss of the temporary repair and the traffic. If temporary repairs do not work, then permanent repairs are needed. A variety of permanent repairs are commonly used to maintain concrete roads. These include maintenance of joints, crack sealing, cross stitching, spall repairs, slab replacement, joint repairs, treatment of slippery or worn surfaces, and slab jacking or mud jacking. All the items except the cross stitching and slab jacking might be easy to understand, and you could refer to the part 5 of the guide to pavement technology for more details. So we take a further look into these two types of pavement repairs, the cross stitching and slab jacking. These are some photos for cross stitching, which is the most widely used method. Cross stitching is a process to retain aggregate interlock across joints or cracks, thereby maximizing shear load transfer at joints or cracks. which are considered to have the potential to open under environmental effects and traffic loading. It is also used at the longitudinal joint to keep the slabs from separating. It involves drilling a 30-degree angle hole from one side of the crack to the other. Drilling dust is removed by compressed air, and a nominal 300 mm to 400 mm length of reinforcing bar is inserted so that it is at least 25 mm below the surface of the pavement. The bar is then fixed in place using epoxy grout as the stitch, and the surface is flattened. The epoxy fixing operation is best carried out during warmer weather or during the middle of the day when the crack will be most tightly closed. These are some photos for slab jacking. Slab jacking is especially concrete repair technology. It could be used where concrete slabs have dropped from their original position as a result of foundation soil sediment sinking or erosion. This treatment stabilizes and underseals concrete pavement slabs by pumping a grout mixture through holes drilled in the pavement into voids beneath the slabs, effectively pushing it up from below. The grout commonly consists of fly ash with approximately 6% cement. The process is also commonly referred to as mud jacking and pressure grouting. Partial depth repair is another way to effectively correct the stresses confined to the upper 1/3 of concrete slabs. This technique has been used successfully to repair spots both at the joints and at mid-slab sections. Proper partial depth repairs can restore distressed pavement, enhance rideability, and remove hazards caused by spots. Partial depth repairs can be a very cost-effective way of repairing pavements for early opening to traffic. You could also watch the video for more information on the partial depth repair of concrete pavement. A summary of this class: routine maintenance of drainage elements includes surface drainage, subsurface drainage, floodways, and faults. For flexible pavement, we have studied the following deflects and corresponding countermeasures. We have also learned the following common deflects of rigid pavement and the treatment. The importance of proper drainage and competent maintenance can mean better roadways keeping within maintenance budgets and can save lives of those who travel over the roadways. You could refer to the websites contained within the slides for more information about the pavement maintenance. All right, that's all I have for you in this lecture. I appreciate your attention and have a wonderful day.